Our first video in the Pre-Calc 12A course is going to involve functions. The first unit in the course is involving functions. So we're going to start by going through an introduction to some basic principles in functions. So I'll just shut this video down. And we're going to start today in this first lesson talking about function. What is it? What exactly is a function? Domain and range. That was mentioned already in prior courses. We'll just refresh your memory on that. We're going to look at function notation, how that works. Again, that was also looked at in a prior course, so hopefully that'll just be a quick refresher. And then we're going to look at some ways to check and see if we're actually dealing with functions or not functions. All right, so on we go. And the first thing, well, what is a function? A function is some kind of a mathematical rule that assigns every element in the x's. So if you have, think of it like so, where you have a series of elements in the x's, and then you have a series of elements in the y's. Well, every element here is assigned to exactly one element in set A. So for example, here could only go to, let's say this was a 1, and this is a 4, and this is a 2, and this is a 5. Well, this would be a function because every element here only goes to one element here. Every element here only goes to one element here. If I had something like this, let's say x comma y, and I had -2 comma 4, 3 comma 5, -2 comma 6. Well, now all of a sudden we have an issue. This is not a function because the element x, see the element -2, it's assigned to two different y values. So for every x value, there can only be one y value in order for it to be considered a function. The other way you would have done this in grade 10 is when you had graphs. So if you had a graph that looked like this, that would be a function. And the way you tested for it was with what was called the vertical line test. If your vertical line only cut the graph in one place, then you knew that you were dealing with a function. As soon as you had this situation, let's say a graph that looked like this, well, now all of a sudden, if I draw a vertical line, I'm cutting the graph in more than one place. This was not a function. This one was a function. This was not a function. This one was a function. So the basic premise of a function is that every first element, which we consider usually to be x's, every x can only be assigned one y value. All right. Domain and range. Domain and range. So domain, we're talking about what x values can a graph take on, and range, where we're asking you to tell us what y values that a graph can take on. Well, first thing you got to make sure we are able to do is identify sets of numbers properly. And what I mean by that is if, for example, I had a number line here that started at -3 and ended at a 4. And let's suppose it went right up to but didn't include -3, but it went right up to and included 4. So if you remember the difference, this one's I would refer to as an open circle, and this is a closed-in circle. And then I wanted every single number in between them to be included. Well, the set of numbers I'm talking about, assuming let's say they're x values, is all the x values that are between -3 and 4, not including -3, right up to it, but don't include it. But I want to include 4 because I've shaded that one in. That would be -3 is less than x, which is then in turn less than or equal to the number 4. So essentially, think of this set. Anytime you have just the single variable in between with the inequations on either side of it, you're identifying x values or numbers or y values, whatever you choose to put here, that are between these two. You always want the smallest number first, just like a number line. Think of it like a number line. Smallest number is always on the left, and your larger number is always on the right. So this would be interpreted or spoken as -3 is less than x, which is then in turn less than or equal to 4, which means what you see up here. Any number between -3 and 4, not including -3, but including 4. There is another, you'll see over here, I put here set and bracket. There's another way to do that using what's called bracket notation. It's basically a way to eliminate the inequalities. This set of numbers right here would go as follows instead. I would go, it's still always smallest on the left, and you just put a comma right between the two numbers, so -3 and 4. And then there's two types of brackets that we use. So in bracket notation, we use round brackets or square brackets. A round bracket means you go right up to, but you don't include the number. A square bracket means you go right up to and you include the number. So for example, this one, I don't want -3 to be part of the set. So I'm going to put a round bracket around that end of it. But when I go over to the number 4, I want to include that number because there's an equal sign there. Then I put a square bracket on it. So this is another way to express this. It's called bracket notation. So for example, if I write out, I'm just going to take my graph here and move this for a second. All right, let's go back here to our bracket notation just to get this down first. So let's suppose I gave you this. I said, describe this set of numbers. What set of numbers am I talking about? So if I said -5 with a square bracket up to 2 with a square bracket. So what I'm saying here is this is the set of numbers between -5 and 2, including -5 and including 2. So on a number line, -5 and 2, include it, everything in between. Versus this set of numbers, let's say round bracket, -1, 0, and let's say this one has a square one on it. This would be on a number line, starting at -1, going to 0, everything in between them. This one is not included. This one is included. See the difference? You shade it in versus leaving it open. Now, if you had a set of numbers that look like this, so let's say you wanted, I don't know yet, oh, sorry for the bad line, but if I had a 3, 4, 5, 6, but this just kept going forever. So when I went to shade it, I said, okay, I'm going to go here. I want all the numbers to the right of 3, and I want to include 3 as well. Okay, so the way this would go would be, so 3 is the smallest number in the set, and I include it, comma, but this goes forever. So when it goes forever, we use the symbol that's kind of like a sideways 8, and that's called infinity. We will do one here in a moment where it goes forever this way. That is what we refer to as negative infinity. So this would be from 3 to infinity. Now infinity is not a number you can ever actually equal. So infinity or negative infinity always has a round bracket on it. Let's suppose I said to you, I want negative infinity to -7. I'll put a round bracket on that one. Give me a demonstration of what am I talking about here. Well, negative infinity is here forever. Let's put -7 here. So -8 would be here. This basically means all the numbers that go from negative infinity, that's the smallest, which is over here, all the way up to -7. So it's this set of numbers. That's what I'd be referring to. All right. If you wrote that out in regular inequality notation, this would be all the x values that are smaller than, not equal to, all the x values that are smaller than -7. If I went to this one here in regular notation, this would be any x value that is bigger than or equal to the number 3. If I went into here, this is all the numbers between these two, including both of them. That would be -5 is smaller than or equal to x, which is then in turn smaller than or equal to 2. So I have those. Alright, so we do expect students to understand and be able to use both of those. Whichever you so choose to use when you're writing out a set of numbers, that'll be up to you. You don't have to do both, but you are expected to understand and know how to use both. Alright, moving on, let's look at this graph and identify the domain and range of it. So if I look at it, now this one has a nice graphic on it to show you what they mean by domain and range. So domain is always on the horizontal scale, what numbers does this graph pass by? So the arrow at the end here means this graph's going to go forever, but it's not going straight up and down. As it goes slightly down, it's ever so slightly moving to the right, which means because it never ends, as that's moving down this way, the x values here, it's going to keep passing and going wider and wider, so it's eventually going to keep passing by all of the x values out this way. It does have a shaded in dot here, so if I was going to write out the domain of this graph, it would be, I'm going to show you the nice fancy set notation you should use. So it's set brackets, look like that. Domain is always x, so it's x values. That line means such that all of the x values are bigger than or equal to -5. So all the x values are greater than or equal to -5. Now we're talking about every single number, decimals, fractions, positives, negatives, everything. Those are your real numbers. So we're talking about the real numbers, which is what happens anytime your graph is all connected like this. If you went domain and you were using bracket notation, x such that -5 square bracket, you don't need to do, in bracket notation, you don't need any of this other stuff because it's already understood you're talking about a set of numbers between two given ones, so I don't need this. Oop. I would go just simply this, or square bracket, -5 to infinity. Infinity always has a round bracket on it. So this or this would both be correct. The range. So now we're looking at what y values does this graph pass by. Well, it starts here on the y scale, and it passes every single y value, and it keeps going forever and ever. So you can see here the domain is signified by the straight line over here, the range. The range would then be any y value such that all the y values are going to be smaller than or equal to the number 5 on the y scale. And again, I'm referring to real numbers. Or if I go bracket notation, it would be, so the smallest numbers are down here. You always have to have the smaller number first, so it can't be square bracket, it's got to be round brackets because it's -infinity is the smallest this ever reaches. The biggest number on the y scale it ever hits is 5, and it includes that one, so it would have a square bracket on it. So there's the domain and range of that graph. Okay, let's have a look at this one. So if I do domain, the domain would be everything between -3 and +1. This graph passes by every single x value between those numbers, not including -3 because it's open, and including 1 because it's closed in. So domain would be x such that -3 is less than x, which is in turn less than or equal to +1, talking about real numbers. Bracket notation, again, I'm going to stop eventually doing both, but for the first couple here, I'll put both. It would be a round bracket on the smaller option, right up to and including 1, with a square bracket, because I can include 1. The range the smallest number it ever reaches is -4, including -4. And then the highest it ever reaches on the y scale is 0. So it's from -4 to 0, including that one. It doesn't quite hit 0 because of the open circle, so it'll be a round bracket on that one. So here it is in bracket notation, y such that -4 is less than or equal to all the y values, which are then in turn less than or equal to, sorry, no equal sign on that one, just less than 0 because of the open circle right here. And then we're talking about real numbers again, or in bracket notation, square bracket on -4 up to and including, sorry, not including 0, so I'd have a round bracket on that one. So there's the domain and range of those two graphs. Now, domain and range can also be determined by looking at functions. If I take this one, for example, there's domain and range for 90% of functions. Domain and range can be anything you want it to be. There's only certain types of functions where there's certain little nuances that you got to watch for. So for example, one of them here would be a square root. And I'd say, well, what are you worried about with that? You can't take the square root of a negative. So if that's the case, whatever's underneath here, which is -2x plus 3, is underneath a square root sign. Well, I can't take the square roots of negative numbers. Therefore, -2x plus 3 has to be bigger than or equal to 0. Otherwise, whatever's underneath there would be a negative value, and I can't take the square root of a negative. I'm going to solve this. Take my 3 over. Divide by -2. Now be careful here. This is an inequality, so when you divide by a negative, you must reverse that inequality to point the other direction. And that would be a positive 3 over 2. So in this question, x can be any number as long as it's smaller than or equal to 3 over 2. That would guarantee that I don't get a negative under there. You can have 0. You can take the square root of 0. Now, if I was going to look at the range, this is the domain. The range, so again, these ones often, you just kind of reason them out, and I say, well, it's a square root. Every time I take the square root of a number, what kind of a value do I get? I get a positive, but then it's got this negative stuck out in front of it. Well, that's going to then ensure that my answer, regardless of what I do over here, my answer is always going to be bigger than or equal to 0. Because if I actually get 0 in here, and I take the square root of 0, I'm going to get a 0, but a negative doesn't do anything to 0, so it would stay 0. So I could get 0, but then other than that, doesn't matter what I take the square root of, my answer is going to be positive, but then the negative out front is going to multiply my answer by a -1 and switch it to a negative. So the range is going to be any y value such that the y values are going to be smaller than or equal to 0. I'm not very good at drawing those set brackets, especially with this drawing pad. Okay, let's look at now. This one just asks for a domain. Sometimes the range can be a little bit more tricky depending on how complicated the function is. This is a pretty complicated function, so we're going to look at only domain. And a lot of times when you're doing domain, what it's easier to ask yourself, instead of what can x be, say, well, is there anything x can't be? Like over here, I say, well, x can't be anything that would make a negative under here. In this one, it's a fraction, so the only concern I would have is we're not allowed to ever divide by 0, which means the bottom or the denominator of this fraction can not be 0. So x could be any other number, I really couldn't care less, except I can't allow the denominator to ever become 0. So what you do is you say, well, take the denominator, x squared, take away x minus 2, and say, well, what would make it equal 0? This goes back to last year's work on quadratics, so I'm going to factor this. I want two numbers that multiply to give -2 and add to give -1. X subtract 2 and x plus 1 equals 0, which gives me x is 2, or if x was -1. So if x was 2, the bottom would be equal to 0, or if x was -1, the denominator would also equal 0. Well, I can't allow that to happen. So the way you do this is you would say x such that x can be any element of the real numbers, comma, and then you put x cannot equal, so an equal sign with a line through it, -1, comma, 2. Now sometimes you might see that, so it could be like x, comma, x cannot equal -1, 2 comes first, and then just to kind of keep that x as an element of the real number always at the end, like that. Another way you could see this written in bracket notation, I just want you to think about this. So I'm going to write it out, and then I'll talk about it in a second. So this would be in bracket notation. It would be -infinity, always a round bracket, up to -1. Then it would, the symbol to join together, so you put a big U, it's called union. That means join together this set. Now we're going to make another set. We're going to go from -1 up to 2, and then we're going to join that together with another set that would be 2 up to infinity. Again, that's another join together or union symbol. So you can see in this case it's certainly more complicated, but if you look at this, this means everything from negative, so on a number line, -infinity, which is here, to -1, let's say -1's there. So I want all of these numbers up to, but don't include that one. Then I want you to start at -1, but don't include it, so leave it open, and go to 2. So that's like this, don't include it. Then I want you to start at 2, don't include it, and go all the way to infinity. Well, if you look at that, that's all the numbers except the 2 holes right here, -1 and 2, which is what I said. X can be any number except -1 or 2. All right, if I go to this one, y is equal to -x to the 4th plus 4. Well, the domain. So ask yourself, is there any number I would fill in for x that's going to cause any kind of undefined or situations that don't exist or something like that? Well, I could put negatives, I could put 0, I could put fractions, I could put positives. I don't see any issue with me putting any certain particular number here. So I think in this situation, my x could be any number. Wouldn't make any difference what it is. Nothing's going to happen. Now in bracket notation, that is -infinity to +infinity. Every single number is written that way. Now the y values, I think that's one we'd say range for as well. If it was a quadratic, we would have looked at it already, but that's not a function we really know what it looks like. So without us actually drawing a graph of it with right now a piece of technology, we really wouldn't have any kind of idea what the range should look like. So we'll just leave it like that and just do the domain. Okay, so that's a look at domain and range from graphs and from looking at some certain types of functions. Function notation. How to read function notation. Well, the first thing is this. You should understand what that means. F at 1. If I translate that into words, it means find the y value when x is this number right here. So in this case, find the y value if x is 1 on the function f. F of 2, what is the y value when the x value is 2? F of x, what is the y value, or what they call the f of x value? That's why they'll say f of x and the letter y are essentially interchangeable. It's the y value at a particular x value, referred to as function notation. So if I look at some examples of this, and you did do this in NERF 10. So for example, if I had a table here and I went, I don't know, -1, 4, 3, 5, 6, 10, and I said, what's f of 3? That was a question. You'd say, oh, that's easy. F of 3 is 5. This is saying, what is the y value when the x value is 3? So you go to your table and you say, well, there's an x value of 3. There's the y value. There's f of 3. Easy, really easy if you have a table of values in front of you. From a formula. So if I said f of x is this, and said to you, what's f at negative 3? Well, that means wherever there's an x, you're going to replace that x with the number negative 3. So for example, f at negative 3 would look like this. It'd be negative 2. I'm just going to put empty brackets for now. So wherever there's an x, I'm just putting an empty bracket. And then you're going to put negative 3. See, negative 3 is in the place where the x used to be. So it's notation that's telling you to replace x with that number. So I'm going to put a negative 3 where there used to be an x. Now we're just going to follow order of operations here and do this properly. So I'm going to have to do the exponent part first. Negative 3 in brackets squared is 9 times negative 2 is negative 18. 5 times negative 3, that's negative 15. Subtract 3, that would be negative 33 minus 3, negative 36. It doesn't have to be a number. I'm just showing you it could be a symbol. F at dollar sign, I don't care what is in here. It's telling me to replace x with a dollar sign. So f at dollar sign would tell me to go to function f, and wherever there's an x, replace it with a dollar sign. It could be a binomial. If I wanted you to find f at w plus 2, that means wherever there's an x, you're going to now replace it with w plus 2. And then you could, I'm not going to go through the whole, well, maybe I will. So then you could expand this out and tidy it up and get a look at what it looks like. So it would be negative 2, square your binomial. So you square the first, multiply and double, square the last, plus 5w plus 10, take away 3, negative 2w squared, subtract 8w minus 8, plus 5w plus 10, subtract 3, collect any like terms. So negative 8w plus 5w, that's negative 3w, a negative 8 and a plus 10, that's a plus 2, a positive 5 and a minus 3 would be a plus 2. Alright, so again we'll use the same function. This is your function, f of x is equal to negative 2x squared plus 5x minus 3, I think at the end, minus 3 was our function. So if I wanted to find f at 2 subtract h, it's telling me put 2 subtract h where the x is. So it would be negative 2 subtract h squared plus 5 onto 2 subtract h minus 3. Square the binomial, square the first. Multiply these two together to give me negative 2h and double it. Negative 4h. Square this one, positive h squared. Plus 10, subtract 5h, subtract 3. Negative 2 times 4 is negative 8. Plus 8h minus 2h squared plus 10, subtract 5h, subtract 3. Collect any like terms. What do we got here? Negative 2h squared, no other like terms, but I got a plus 8h and a minus 5h. That'd be a positive 3h. I have a negative 8, a plus 10, that's a positive 2, and then a minus 3. That would give me a minus 1. I think I might have missed a number over here, did I? I did. I had a minus 8 and a plus 10. That was a positive 2. But then I had subtract 3. There should have been a minus 1 at the end here. Sorry about that. So this should have been subtract 1. Okay. So that is a refresher on function notation. probably didn't do any with binomials like this in NERF 10. You did do the other ones. But yes, it does expand in this course to you to be able to substitute a binomial or trinomial, or it doesn't matter what. Just understand how function notation works. So I've got a couple quick examples we'll look at here. So here's f of x, and let's say I wanted to get f at 0. Well, f at 0 would be 3, 0 squared minus 0. Well, 3 times 0 squared is 0 minus 0, that one's 0. F at 1, 3 times 1 squared minus 1. 1 squared is 1 times 3 is 3, minus 1 is 2. F at negative 2, 3 times negative 2 squared minus a minus 2. Notice you always put it in brackets. Negative 2 in brackets squared is a positive 4. Multiplied by 3 is 12. Minus a minus, so that's plus 2. That's 14. F at a half would be 3, replace x with a half, squared minus a half. 1/2 squared is a quarter. The number 3 is 3 over 1. 3 over 4 minus 1/2. Common denominator would be 4, so it's 3 over 4. Take away 2 over 4, giving me 1/4. F at A. Scroll up so I can still see my function. So f at A should be an easy one. It's just 3, replace x with a squared minus a. 3a squared minus a plus 1. So 3a plus 1 squared minus a plus 1. Square your binomial first. So square the first. Multiply these two together, which would give you a positive a. Double it. Square the last one. Take away a, take away 1. Make sure the negative distributes to both of those. That's why the brackets are important there. Often here students won't put the brackets on here, and the negative will only go to the a, and they'll have the wrong sign on this one. Now distribute the 3 into the bracket. 3a squared plus 6a plus 3. Subtract a, subtract 1. Couple like terms, so 3a squared will stay here. 6a minus a, that's a plus 5a. A plus 3 minus 1, that's a plus 2. Okay, so that's function notation, which I think is where we're going to end. I don't think we're going to do that second one. So we are just going to stop there. That's a good introduction. I want you now to use the practice questions provided to make sure that you understand this material, and then we'll do a quick checkup on this and continue on with our journey through our unit on functions.